Hi, everyone. Hope everyone had an amazing lunch. Thank you for coming back on time, and we will go on with the rest of the demos. Before we do, I just want to say a very quick thank you to blockslive.tv for providing this live stream for you guys so you can watch this at home, and wish you were here, like all of you probably are right now. So maybe we will see you, the rest of you, next year. Also want to do a quick shout out to eToro, who will be sponsoring the after event drinks on Saturday night. So without further ado, I'm going to hand it off to our other co-host. Yes, Blocks Live. Thank you very much, guys. Amazing live stream. Love it. I'm going to hand it off to Giacomo for the introduction of our next demo speaker.
Thank you, Tone. So now 2 demos about, we discussed the importance of running a full node. The ideal situation will be, how many of you are running a full node right now at home? Raise your hands. So it's a good percentage, actually. I was more skeptical. Let's try to get the other half of the room to run a full node before the end of Sunday. In order to do that, now we see the 3 different flavor of this that you actually, a flavor that was not discussed in the panel, which is the from scratch installation on Linux. You can have a Linux machine, which is can be an old laptop or maybe a specific instrument like an Odroid or a Raspberry, and on top of that you can install from scratch. Alekos Filini, developer for Blockstream and the Green team, will give now you this introduction, also talking about something that usually non-technical user don't really understand or do very often, which is verification of the binary that they are going to install. So sure, you have to be your bank, you have to enforce your rule, you have to run your full node, but how do you know that the software you're running is actually the source you can review? Did you compile everything from scratch deterministically or not? So one answer, which is a little bit easier than compiling, is at least verifying signature, which is something that Alekos will show you at the beginning, something that is a very good, it's a best practice that we all should learn to do. It's a little bit like running a node. You don't need it until you do, and when you do, because there was an attack, for example, the Electrum, the fake Electrum software with a malware or other kinds of attack, then it's too late. So please pay attention to this presentation, and on Sunday you can try to do this again on your own machine with our help. Thank you, Alekos.
Hi everyone. Hi everyone. Can you hear me back there? Okay, so well, basically Giacomo already did my whole presentation. My whole presentation is targeted to like very beginners. So it's just how to install core, with like going through all the let's say steps to make sure you are getting the right code and the right binaries, and yeah, and basically make sure that you are actually running the right full node, the right rules. So I'm Alekos, as Giacomo said. I'm currently an intern at Blockstream, a developer, and the presentation is core from scratch. So this is like a little overview. We're going to talk about, like, it's very for beginners, so basic Linux commands that you should know in order to replicate that, how to download core and how to verify the signatures, how to set up a system service so that core starts automatically at startup, some common configuration options, like the most popular one that you might need. And then the last part, unfortunately, I won't be able to show the practical demonstration of that. It's a project I'm working on that eventually will lead to a guide published on GitHub. And it's basically a way to run core in a virtualized environment on a single board computer similar to the Raspberry Pi. It's a bit more advanced, but I think it's kind of cool. So I will talk about that. Unfortunately, I won't be able to show it, but yeah. So let's begin. First of all,
we can show the machine, but
yeah, this is the thing, but it is not plugged in, and yeah, it doesn't work. So just to make sure that everybody can follow the rest of the demo. This is the Linus cheat sheet. So it's basically some basic commands that you will need to know to understand what I'm doing. So there are like commands to move around directory, so change directory, list the content, create a new directory, copying and moving files. Then there are commands to like run other commands as administrator, so this is sudo specifically. There are commands to handle permissions and users, so create users and change the ownership of, for instance, a folder, so that a user can or cannot write and read from it. There are commands to download files, like wget, text editor, like Vim, and I'm also gonna talk about them and show what they do once, like while I'm doing it. So this is just to give a little introduction to that, and then I'm gonna actually run them. So the main topic of the talk is actually what Giacomo said. So you should always verify signatures of what you're downloading. This is in general a nice rule to follow, but it's particularly important in the case of Bitcoin because there are many implications that are kind of like in general you should verify signatures because you might, I don't know, download accidentally a malicious software like a malware or something. In Bitcoin it's a bit more complicated, I would say, because yeah, you could always download a malware, but you could also download a actually fully validating node, but that follows the wrong chain maybe, so that I don't know, has different rules than what you want your node to do. So you always verify signatures in general, especially in the case of wallets. And the cool thing about checking signatures is it's kind of a weird thing. It wasn't so obvious to me. I actually realized it after a while. After I started working on it for a while. It's basically that by checking signatures, you're not completely removing the need of trust, because you still need to trust, first of all, the signer of the binary you're downloading, and also that you actually downloaded the right public key against which you are checking the binaries. But the cool thing is that you, instead of doing this repeatedly every time you download a new software, you just do this once when you first import the public key of the signer, and then after that you will, as long as you just don't change it, you will be able to verify as many signatures as you want. So it's not that you are like removing completely trust, but you are minimizing it, and you are like going from a linear kind of scheme to a constant kind of scheme. You just do it once, and then it's okay forever. But yeah, there's this one step you have to do, which is importing the public key of the signer, and this kind of requires trust. So if you look up on Google the GPG public key of Vladimir, which is currently the maintainer of Core, how can you make sure that you're actually getting the right public key? Because the reason why we check signatures is that we are afraid somebody could, I don't know, like intercept our traffic and swap the binaries on our behind. So if an attacker can do that, why cannot he do that the same for the public key? So why cannot he gives us the wrong public key? And the answer is that it actually can. So in a model where the attacker can change the binary, it can also change the public key. And this requires a bit of trust. So what you would normally do in GPG is basically talk to people, verify the identity of other people, and then go like in a web of trust way. So if you verify the identity of a person and this person verified the identity of another person, you are fairly confident that this third person is probably the right person, because there's this kind of connection. And another way is to just to ask other people, and this is what I did today. So I asked a couple of the other speakers if they could double check with me what was the right public key, and we all came up with the same answer, that this is the currently the public key used to sign Bitcoin Core releases. So you should all take a picture, even better, write it down on a piece of paper. So because you never know, maybe somebody could change the file on your phone. This is currently, many people verify that, currently the public key of Vladimir, which is the maintainer. So once you have this piece of information, this is just the ID of the GPG key, you can basically download whatever you want and verify that it's actually signed by this public key. And one thing I forgot to mention, one thing that you still have to keep in mind is that signatures are not going to expire when a new release when a new software is released. So you should not only verify signatures, but you should also verify that you are downloading the latest release of a software. Because even if a software is legit, like an older version of Bitcoin is actually the legit version, it could still be buggy maybe, could have some vulnerabilities. So even if the signature check actually passes because the file was legit, if it's an old release, it might have bugs. So double check that you're actually downloading the latest version. So now we're actually basically gonna do that. I'm running on my own laptop. The original plan was actually to, as I said, do this on the Odroid. So in this case, the process could technically be simplified because I'm running commands on the same laptop I'm running this browser. But just to keep it the most generic as possible, I will do it the way that you would even if you were connected to like a remote server or a remote single board computer like I was planning to do. So we will open a terminal. And I'll try to keep them side by side like that. And if it's too small, I will just switch to a full screen setup. I think it's big enough that you can see even from behind there. And basically, I'm just going to go through the instructions that are published on bitcoincore.org. If you go to the download page of bitcoincore.org, maybe I'm gonna just make it a little bit bigger. This is bitcoincore.org. You go to the download. I don't know. I can maybe do that. Yeah. Yeah, I'm just going to ignore the top one and use the bottom one. So is it okay? Can you see? Yeah. Okay, so once again, it's nothing too complicated. If you are a bit, I don't know, like a techie, you could probably do that by yourself, but I'm just going to go through it and explain the process a little bit. You go to bitcoincore.org and download, and you have to pick the right version. This is a generic Linux guide. So first of all, you have to choose if you are going to download the normal Linux, which is the x86 Linux or the ARM Linux. The rule of thumb is if you are on a normal computer, on a laptop, you go for the generic one, let's say, 64-bit for newer computers, 32-bit for the older ones. If you are on like a Raspberry Pi, you will normally go for a 32-bit. This is like for most of the single board computers, so like the small boards that you have. You will go for the 32-bit Linux version. I'm gonna go for that because I'm on a laptop, and what I'm gonna do is like right-click and copy the link, and then go to the terminal, which is once again now it's locally, like I'm running this locally, but it could be on a remote location, and type wget, which is the command to download files, and then paste the link in there, and just hit enter. And the Wi-Fi here is pretty slow, so we're gonna wait for a while. In the meantime, I'm just gonna go through the other steps. So this is what I'm downloading here is a tar package, so it's like an archive that contains all the binaries pre-compiled of Bitcoin, so you don't have to compile it yourself, you just extract it and it works. And we also need two other files. The first one is this link that I'm gonna once again copy and paste on the terminal, which is the file that contains Vladimir's public key. So once again, here is this is the ID that is once again copied there. That was the one I was showing before, and we will download this file and import it and make sure that the ID actually checks out. And another thing we're gonna download is the SHA-256 sums of the file, which is used to check the integrity of the archive we just downloaded. Basically, if you follow the instruction under Linux verification instruction, you're gonna do what I'm showing right now. So this is almost done. I'm gonna prepare with the other link, so I'm gonna copy the public key, the GPG public key to download, and once again, wget and paste, and hit enter. This is much smaller, so it's gonna be faster. And then last thing, I'm gonna download the SHA-256 sum. Okay, so first thing, this is something I'm doing because it's like the first run ever. I'm gonna import Vladimir's public key. This is a step you do only once, the first time you import the public key. And this is like GPG. GPG is the command that is used to manipulate and verify and create signatures. GPG --import and the file, which is this one. hit enter. Now at this point you cannot see the fingerprint, which is the ID I was showing before. It's not a big deal. We will see it later when we actually verify the signatures. Now the pub key is imported and it's there, so we can keep it and verify signatures later on. Second step we have to verify is make sure that the archive we downloaded is, let's say, it's the correct one. Its integrity is we can verify its integrity. And the reason why we do that is that usually what the maintainer of core do is that they sign the list of the hashes of the archives instead of directly signing the archives. So we will first verify that the archive matches the hash we expect, and then verify that the list of hashes is signed by the with the correct public key from the releaser. So this is the command that is written down here. It's SHA-256 sum. These extra flags are basically to avoid creating confusion, avoid extra errors. This is because the list of hashes contain one entry for every architecture, like all of these versions appear, so the Windows version, the macOS version, and we're just going to tell him to ignore the missing files, just checks the file that he can find. Then it's -- check, and we provide the list of hashes, which is this one. And as expected, we're going to have this warning because there are some other lines, but the important thing is that the file we downloaded, which is the x86 64 version, is okay. So it checks out the hash of the file we downloaded is the same that we were expecting. And so finally, we can verify the signature on this list of hashes with GPG, which is this command right here, GPG -- verify SHA. And here the GPG says this is a good signature. This is not really important. Like the name here can be manipulated. I could create a key with this string, with this name. So you should not look at that. You should look at the part down here where you have the ID of the public key. And this is where you should check that it matches the one you wrote down before or the one you saw on the slide before. So everything checks out, so we're good to go. We can proceed to unpack the archive. We do that with tar. There are many options that you can use. What I would normally do is XVF. X stands for extract, V for verbose, so it will list the file it is extracting, and F because we are providing a file to extract, which is Bitcoin. And as you can see, while it was extracting a file, it showed all the files that were in the package. And now I'm just gonna copy it into my I will call it system directory so that I have it ready as a command. To do that, I need to run this command as an administrator. So I will first prepend the command with sudo, maybe, yeah. So it's gonna be sudo to run this command as an administrator, cp for copy, -r for recursive, and I will also add a v, which is just for, once again, verbose, to have a verbose output. It's not required, but it's useful to see what's going on. This is the folder that was created when we extracted the package. So we're going to say everything that's contained in this folder, just copy to user, which is our system directory, basically. And this is a list of the files that were copied with the new path they were copied into. So these are the most important ones, like Bitcoin D, Bitcoin CLI that we're going to use. These others are libraries that are used by Bitcoin that we could also use if we wrote some kind of software that would interact with libbit consensus. And then we have the man pages that are just useful if you have to check some, I don't know, options for Bitcoin Core. So now Bitcoin should be installed. We can check that by running Bitcoin D -- version, for instance. Yes, it's installed. It's version 0.17.1, which is the latest release. You can check it here. You can check it on GitHub. You have many places to check that. And now if we start like Bitcoin like that, it would start syncing the blockchain. We actually don't want to do that right now. We will first set up the system service I was talking about, which is basically like a list of instructions that tells the system to start Bitcoin D when you boot up the operating system, to, for instance, restart it if it somehow crashes for some reason. And it's also a safety measure in a way, because there are many instructions in this system D service that will tell the system to run Bitcoin in the, let's say, most isolated way possible, so on a dedicated user and with very low permissions. So first of all, we need to download this unit file, the systemd files, and you can find it on GitHub. So you open the main Bitcoin page on GitHub, you go to contrib, init, and you get the bitcoind.service file. What I would normally do to download it is just go to the raw option, which is just the file, copy the link up here, and once again use wget to download this file. This is a text file, it's very small, and I will actually open it just really quickly to show it. This is basically a kind of metadata file that's interpreted by systemd that says that we are declaring a service called Bitcoin daemon that should start once the network is ready. And what should be run is this binary, which we just copied, with this option, which are daemon is to run this in background, with this configuration file, using this as data dir. You can actually change, if you have like an external hard drive to store the blockchain, you can change this data dir and point it to the external hard drive. I'm just gonna leave it like that and use my internal hard drive. These are some options to tell the system to restart Bitcoin on failure, so if it crashes for some reason. We're gonna run it as a Bitcoin user, so we're also gonna create a Bitcoin user that has low privileges, so in case your node gets, let's say, hacked, or if it misbehaves by itself for some reason, it is going to be running as a low privilege user, so it's not going to be able to affect the whole system, just going to be able to affect its own file, like the Bitcoin, the data dir, so this var lib bitcoind, or maybe the configuration directory, but nothing more. So it's kind of a protection, the extra protection that we can add. And we're also going to declare that these folders should have these permissions. So this is once again to ensure that even if something wrong happens, bitcoind cannot like take over the whole system and hack your computer. And that's basically it. This is the most important part. So we can close this file. First of all, we are going to copy this file into the proper directory. And once again, we need to do this as an administrator. So we're going to use sudo cp. Once again, I'm going to put a v so that we can see. This time, there's no r, because r stands for recursive. So you use that when you have to recursively copy a directory. But in this case, just a single file. So we can just use -v. This is the file, bitcoind.service. And we have to copy it over in lib systemd system. And yeah, the system is telling us that this file was copied there. And now we need to reload the list of services installed on the system. So this is sudo systemctl daemon reload. This is just gonna reload and basically go through all the directories and look for new services like the one we just added. Last thing, we need to create this Bitcoin user that's just gonna have very low privileges, so it's not gonna be an administrator of the OS, just a normal user. And to do that, we just do sudo user add Bitcoin. And we're just gonna leave that there for bitcoind later to run. Now, last step before we can actually run the daemon, we have to create is a configuration file, which was declared here in the service, and this etc bitcoind /bitcoin.conf. So we are first going to create this folder and then place this file in there and add some configuration options that we want to add to our node. So first of all, once again, as an administrator, because these are like system folders, sudo mkdir, we can add a v once again just to see what's going on. etc bitcoin, and then, yeah, the first time I made a typo, this is the correct one, etc bitcoin. And then we're going to create the configuration file in there. So sudo vim as a text editor, etc bitcoin.conf. Now, there are many configuration options that you could use. I remember somebody mentioned this before. There's a really cool configurator made by Jameson Lop. So you can just look on Google Bitcoin configurator. I think this is enough. Yeah, this one, the Bitcoin core config generator. You can use that to generate some kind of template-based configuration files. So this is the default file. It's basically, it doesn't have any option because all of these are comments because they are commented out. You could create a profile for a low disk usage if you want to. So this configuration specifically has a deep pruning enabled to reduce the size used by the blockchain. You could run on the testnet or regtest. This is a very good place to check for configuration options. I will basically just enable the transaction index, which is TX index. This takes a bit more of space and also makes the initial block download a little bit longer. But in general, in my for my usage, so that I use it for Lightning and also for development in general, this is a pretty cool option to have because it lets you basically poke the blockchain around. You can get transactions, even very old transactions, and you can basically explore the blockchain, the entire blockchain. So I normally just use that. If you have low space, you can, as it says in this configurator, you could use the low disk usage profile, which is just pruning. So prune maybe 10 gigabyte. This is the space you want to allocate for the blockchain. You could do 20, 30, however you want. Or you could, if you want to run on testnet, you can add the testnet option. That's up to you. I'm just going to stick for the TX index, which is interesting for me. And then I will also set the credential for the RPC so that I can connect to BitcoinD and interact with it. So I will create an RPC user, just a generic, I don't know, admin, and an RPC password, admin. Once again, don't do that, obviously, it's just for the demo. And I think this is basically it. Just for this basic node, we can go with that, and you can personalize it for your need. So we're gonna save this file. Last thing we have to do, just make sure that BitcoinD, once it is gonna run, can see this file. So we need to change the permission on this folder we just created, which is etc Bitcoin. Instead of changing the permission, we will change the owner altogether. So we will just tell the system that Bitcoin, the user Bitcoin, is now the owner of this folder. And to do that, we use change owner -r once again, because this is a folder, so we need to do that recursively. It's Bitcoin, and the folder, which is etc Bitcoin. Okay, so now we are finally ready to start BitcoinD, and it should work, unless I forgot something. And to do that, we should do sudo, once again as an admin, systemctl start BitcoinD. Let's see. Okay, so we didn't get any kind of error, so now BitcoinD is running in background. We can check that through the Bitcoin CLI, which is a tool that it can be used to connect to the RPC of BitcoinD and interact with it. So we run Bitcoin CLI. We have to provide the user and the password we just created, so admin RPC password. And then one command. I will go for a get blockchain info just to see what's going on with the blockchain. You have many more commands. I will just show them very quickly right now. And it's a bit too much to show in this screen. But this basically means that, first of all, Bitcoin is running, because otherwise we wouldn't have any kind of output. And then we see that we are actually at 0 blocks, so it's still in the very initial phase of the sync. It's probably downloading the headers. We can see that we are running the initial block download, and then there are some informations about the various activated for soft forks that at this point in time at block 0 are not activated yet, but are going to be activated going on through the sync process. There are many other commands you can try. Most of them are pretty, I would say they're not dangerous to run, especially if you're not using BitcoinD as a wallet. So you can use the help command to list them, and this is going to return a list of all the commands that the RPC accepts, and you can try them, and they are like divided by category. So there are wallet commands, so there are raw transaction. These are the most advanced commands that you can use to create PSBT transactions. There are network information, so you can see how many peers you are connected to and how many peers have been banned, all this kind of stuff. And now you basically just have to wait for it to sync. So you can run this command many times. Now it's already synced almost 200,000 headers. So first of all, it will sync up all the headers up to the current block, which is around 500,000, 550,000. And then we'll start downloading the blocks. Once the whole process is done, this initial block download will turn to false because the node will actually have recognized that it is synced with the main blockchain. And at this point, you will have a fully validating node running that you can use for whatever, for Lightning. It would be for maybe an Electrum personal server that was mentioned before. You can basically do whatever you want with your node. Now, I think I'm going to be, I think I have still some time, maybe 5 to 10 minutes. So I'm going to talk very quickly about the whole thing I wanted to show, the virtualization thing. And then I will accept questions if you have some. Also, I'm going to be around, so yeah, I'm going to be here. So this last slide here. This is basically a project I'm working on to basically reproduce the setup I showed with the node on this hardware right here, the Odroid. But the cool thing about the Odroid is that it's actually pretty powerful, so you could use it not only for your Bitcoin node, but also for other stuff. You could use it obviously as a Lightning node, as a block explorer, even for non-Bitcoin stuff, so as a Tor relay network or as a home server that you have in your home. But this creates kind of a security issue because the more software you install on your node, the more you are exposed to risk. This is basically the talk that we were having before for the hardware wallet. So an hardware wallet is basically a device with as few lines of code as possible on it, so that it's easier to audit and that it's safer. And here I'm talking about installing more software on your node. So this is like the opposite thing. And the cool thing about this particular hardware, the Odroid, is that you can actually set up virtualization. So you can have, instead of running all these commands, all this software directly on the Odroid, you can use it to create some virtual computers inside of it, some virtual machines, and install the software in separate virtual machines so that they cannot affect each other in a way. So this is very similar to Cube's OS model of having different software run in different virtual machines. And the cool thing about virtualization is that you can actually you can basically control everything. So you can choose which VMs can talk to which other VMs. So you could, for instance, have a Bitcoin VM which can talk to the Lightning VM but cannot talk to the media server VM, because obviously your media server that stores movie doesn't need to use the blockchain. And you can basically keep it safer this way. So this is a project I was working on. I was planning to make a guide that will hopefully be on GitHub maybe in, I don't know, 1 month. I will not say 2 weeks because really not going to be in 2 weeks, a bit more. But yeah, if you're interested in that, just keep an eye on my GitHub or my Twitter, and I will hopefully finish this project and publish the guide. And I think that's basically it. So we have some time for questions if you want to.
We have maybe 5 minutes if someone has a question they really want to ask, coming up to the mic. Otherwise, we'll move on with the next demo on nodes. All right. All right.
Okay.
Awesome.
Thank you, Alekos.
Thank you so much. Here, maybe we'll done with the live stream. All right, Udi, come on up, set up.